Welcome back, and it is my distinct pleasure now to introduce Professor Ryan Cavallo, who is the Chief Medical Officer and also Global Head of Nutrition Product Development Center Nutrition. He earned his medical degree from Bombay University, as well as completed his pediatric residency in New York and a clinical fellowship in pediatric gastroenterology and nutrition at Johns Hopkins University. And he also has an executive MBA from the Ohio State University. Prior to his current role, Dr. Cavallo held several positions in academia, most recently as an adjunct associate professor of clinical pediatrics at the Ohio State University here in the US. He's a member of the North American Society for Gastroenterology, Hepatology, and Nutrition, and also the American Academy of Pediatrics. He served on several boards and committees over the last 10 years, and has written about 30 articles in peer-reviewed journals and contributed chapters to textbooks, educational DVDs, and webinars.
Hello. Today, we're going to talk about human milk bioactives, but really looking at what tomorrow holds, and we'll talk about future perspectives. What we do know is that breast milk provides the optimal levels of macro and micronutrients to support infant growth and development. Over the years, the well-established paradigm holds true for the future, that breastfeeding and breast milk is the best way to feed a child. What we've learned from the research over the many decades is that the components that are present in breast milk have a variety of biological functions, which really contribute to immune development, protection against infections, gastrointestinal development, the gut microbiome, neurodevelopment, and metabolic health. What we've learned over the recent decades is that it also contains non-nutritive components. And we look forward to actually better understanding these non-nutritive components, and particularly their impact on health outcomes. A lot of people refer to these non-nutritive components as bioactives. So over here, I've put a summary of the literature published definitions of bioactive. Bioactives are defined as components in food that influence physiologic or cellular activities in the animals or humans that consume them. Bioactives are also defined as components that have an effect on living organisms. More recently, they've been components of food and are defined as elements that affect biological processes or substrates and hence have an impact on body function or condition and ultimately health. Another way to look at it, specifically for human milk, is that human milk has distinct bioactive components that are thought to protect against infection and inflammation and contribute to immune maturation, organ development, and healthy microbial colonization. So let's start by looking at the nutritive or the macronutrient contributing components of human milk. As we'll see from the data on the coming slides, is that the concentration of lactose, which is essentially the only sugar in human milk, is the least variable of the macronutrient components. And higher concentrations of lactose are found in milk of mothers producing higher quantities of milk. Human milk fat is unique and characterized by high contents of palmitic and oleic acids. Palmitic acid is really heavily concentrated in the 2 position, and the oleic acids in the 1,3 positions of triglycerides. Specifically, the fatty acid profile of human milk varies in relation to maternal diet, as we've seen from the plethora of data on the component influence of maternal diets and long-chain polyunsaturated fatty acids. When we talk about proteins, the most abundant proteins are the whey component, and within the whey component, there is alpha-lactalbumin, lactoferrin, secretory Iga, lysozyme, serum albumin. And of course, outside of whey, there is the casein component of human milk. And when we talk about micronutrients in human milk, they vary depending on the maternal diet and the body stores, even preconception. And these are nutrients like vitamin A, the B vitamins, D, and iodine. What we do know And that's why the recommendations are for vitamin K at birth and vitamin D supplementation, including in breastfed children, is because the breast milk tends to have low levels of vitamin K and vitamin D. Let's look at the data. Historically, data from the 1990s and early 2000s really has quantified the various macronutrient compositions of human milk. In this composition of the data, which is really coming from the US, Danish cohorts, and Australian cohorts, what we see is that there is a variability in the human milk macronutrient profile in different countries. However, when you look at these studies in greater detail, you realize that the way human milk is collected, the way it is stored, and the way it is analyzed is really also a significant contributing factor to some of the levels that we see. What we do know from the data is that a lot of this variability is clearly explained by maternal factors, the time when you collect human milk after you deliver the baby, the gestational age, and of course, as I said, the collection factors. In some of the more recent studies, particularly Sagar Thakur's publications from 2013 and another recent study in 2016, really tells us these compositions vary over time. What we also know from the more recent data is when you look at the composition of these macronutrients in preterm versus term milk, you will see that there is a compositional difference, with components like protein being significantly higher in preterm babies than controlled and compared gestational ages, as well as time post-delivery in term babies. One very important component of human milk, which provides both nutritive and exquisite functional benefits, is colostrum. Colostrum, while produced in low quantities in the first few days postpartum, is very rich in immunologic components such as secretory Iga, Lactoferrin, leukocytes, as well as developmental factors such as epidermal growth factors. So now let's look at some of these bioactive components in human milk. The first question that often gets asked is, where do these bioactive components in human milk come from? And the three among the few big sources of these bioactive components are either they are produced and secreted in the mammary epithelium, or they are produced by cells carried within the milk, or they could be drawn from the maternal serum. And when we talk about these bioactive components in human milk, it's good to understand that there is an exhaustive list. What I'm going to show you here on this slide and on one of the subsequent slides is just a small fraction of the exhaustive number of bioactive components that are present in human milk. Among the more well-studied ones are human milk oligosaccharides. And we'll talk a little bit more about them, but in general, they provide prebiotic and stimulating beneficial colonization, really promoting more probiotic and reducing colonizations with pathogens. They also have a role to play in inflammation. Another important component is gangliosides, which we know have a role to play in cognition as it relates to brain structural development, and more recent data also shows their role as an anti-infectious agent, particularly along the gut. Other factors are mucins, chemokines, cytokine inhibitors, and growth factors. And to continue a fraction of that list, you will see that there are also hormones, which have obviously a bioactive component, which come from the mother's milk to the baby. The antimicrobial factors, particularly the antimicrobial bioactives, have been reasonably well studied. And the three big ones that have been studied and published in the literature include lactoferrin, which really is an acute phase protein, chelates iron, and has both antibacterial, anti-inflammatory, and antioxidant components. Lactoferrin, which is shown in some animal models to have antiviral, inflammatory, really actually inducing more apoptosis, as well as modulating the inflammatory cascade. And obviously the data on osteoportin, which shows it to be a multifunctional protein with an impact to immunity. Metabolic hormones are increasingly studied today. Among them, adiponectin has a role to play, not only from a metabolic perspective, but also showing promise as its effects as an anti-inflammatory. When we look at the cellular components in breast milk, macrophages really having a role to play in T cell activation and protection against infections. And of course, as is very well known and very well published, immunoglobulins. What is important to note here is while we always talk about secretory IgA, it is important to note that later on in the lactation, you also have quantifiable levels of IgG and IgM. So let's start by looking at HMOs. This is well published and well discussed over the more recent years and has been talked about from its original publication, which came out in the 1950s, based on the work by Paul Bjorgi, the pediatrician in the US. When we talk about HMO diversities today, we know that there are over 150 that have been categorized. But among that are measured, we know that there are three core groups: the non-fucosylated HMOs, the fucosylated HMOs, and the sialylated HMOs. And they really have been shown to have a role in influencing health. The data today shows their role in immune health, in metabolic health, in brain development and cognition, gut health, and bone health. We also know that both from in vitro, in vivo data, as well as from some clinical data, that we see the impact on the microbiome. Further exploration continues to happen for their role in bone health, allergic disease mitigation, as well as, in general, infection protection. But as we look into future perspectives of bioactives, it's good to realize that there are other immunologic factors in human milk as well. This slide really characterizes them in terms of alpha-lactalbumin, lactoferrin, secretory IgA. But the data is really interesting over here because you can see that their quantity varies over time. So their levels are not static, and it shows the biological dynamism of human milk and how the maternal infant feedback mechanisms also have a role to play in addition to the duration post-delivery. When we look at some of the cellular components of human milk bioactives, it's important to note that human milk has a large number of these cells, including macrophages, T cells, stem cells, and lymphocytes. And in this beautiful diagram, which is published in Nutrients in 2019, you can see how these cells impact the various cytokines and their downward cascades, which help both with immunity, immune modulation, and various impacts in their role in microbial colonization, as well as prevention of other infections. About 80% of the cells in early milk are macrophages, and they really originate from PBMCs that exit through the bloodstream, talking about the mechanism by which they come into the mammary epithelium. These cellular components, as is shown in the picture here, offer broadly powerful protection against pathogens, which is really critical when the infant is first born and its immune system is developing. When we talk about protections from infections, which is a key component and a key impact of the value of exclusive breastfeeding, we see that secretory IgA is the predominant antibody of human milk. But milk also contains, as I alluded to from the data before, IgM and IgG, which become more abundant later in the process of lactation. Human milk SIgA antigen complexes are taken up by these dendritic cells, which allow for antigen recognition while maintaining a non-inflammatory environment, which can really help the host tolerate versus react to certain antigens. Lactoferrin, we'll talk a little bit more about it, but just in general is an ion-binding glycoprotein, which really is effective against many bacteria, and newer animal model data also shows its role against virus and certain fungi. Lactoferrin prevents rotaviral infections in newborns. But following infection or damage, it also mediates certain phagocytic uptake, and this shows its role in immune modulation. Additional multifunctional proteins are also found, which have a role to play in protecting the newborn baby. So let's look at secretory IgA. It serves as one of the early line of defenses in protecting the baby by bolstering the intestinal epithelium from anaerobic toxins and pathogenic microorganisms. The way it does this is by interfering with the earliest steps in the infection process by virtue of its ability to block pathogens from adhering to the intestinal epithelium. It's the ability of Secretory Iga to promote the clearance of these antigens and the pathogenic microorganisms from the intestinal lumen, which really has a role to play in facilitating their removal and hence protecting the baby against infections. When we look at lactoferrin, this molecule is quite complex, but it really has a role to play in boosting up the immune responses through its influence of interferon gamma, TNF alpha, and other cytokines which modulate the inflammatory cascade. Lactoferrin enters the cells by receptor-mediated endocytosis, and then it is released within the cells once the receptors are digested by endosomes. Lactoferrin has a significant role not only in the inflammatory cascade, but also in certain other factors which really impact iron levels. Osteoportin is yet another bioactive protein. Osteoportin activates the cellular immune system, binds to bacteria, binds to monocytes, promotes monocyte migration, and induces phagocytosis of bacteria. Gangliosides, yet another well-studied bioactive component, really talks about the diversity of gangliosides, and there are different kinds of it, and you can see here from the data which came out of a publication from China the varying levels of gangliosides in human milk depending on the different regions where mother's milk was collected in China. What's important to note is that gangliosides are a complex structure which are composed of a carbohydrate as well as a lipid, in this case, a sphingolipid. When we look at antioxidants in breast milk, it's important to realize two things. One is, as you can see from the data in the first chart here, that the antioxidant levels tend to be significantly higher in preterm mother's breast milk compared to term mother's breast milk. When we look at some of the endogenous antioxidants, they really have a role to play as antioxidants, eliminating superoxide ions, hydrogen peroxide, but also have a role to play in regeneration of other antioxidants. You can see here that the levels range depending on different times of collections and different data sets from geographies. Adipokines is one of the metabolic proteins that we talk about when we talk about human milk bioactives. Among them, adiponectin tends to be the most abundant. They really have a role to play in regulation of lipid and glucose metabolism. But what is really interesting, in addition to its improvement of insulin sensitivity, is its role, as we now understand, as an anti-inflammatory component, which really explains the multifunctionality of these various breast milk bioactive components. When we talk about adiponectin, as we saw, it is a large multifunctional hormone that regulates metabolism and suppresses inflammation, in addition to its metabolic contributions. So when we start to look at all these things together, what we can see is breast milk is a complex, uniquely designed nutrition, which is uniquely designed for each mother-infant dyad. It is a complex of microbiologic, immunologic, and metabolic factors in breast milk, and has a large role to play in delivering some of those immune benefits, gut benefits, protection benefits, atopic benefits, neurocognitive benefits that we see comes from exclusively breastfeeding a baby. This chart here summarizes some of the microbial factors, immunologic factors, and the metabolic factors, and their complex interactions with each other that enables every child achieve their growth potential. But when it comes to the question of, as clinicians, what can we do to really influence some of these bioactive components in mother's breast milk? Well, we know that there are various factors that can impact the quality, the composition, the characterization, and the quantity of these human milk bioactives in mother's breast milk. These range from certain non-modifiable factors, like mother's genotype, to modifiable factors like mother's diet, physiologic state, the mode of delivery, the gestational age, the lactation stage, the underlying medical conditions, medication use, and then maternal BMI. Because we know by proactively educating and creating awareness on the importance of the modifiable risk factors, we can really influence infant clinical outcomes, ranging from infectious disease, allergies, the growth in body composition, cognitive development, immune system development, and metabolism. So finally, what we've learned today is that human milk contains a plethora of varying quantities of bioactive components. And what we learned is that they continue to offer much promise as we further our understanding of the health benefits of breast milk. As we look towards the next generation of research, the opportunity is to focus on the complex interactions and the interrelationships between these various bioactive components in human milk. We should continue to forge ahead in better understanding of the maternal factors that may influence the expression of these bioactive components, and this is critical information to improve maternal health solutions that enable continued and exclusive breastfeeding. And finally, understanding the bioactivity not only of term mother's breast milk, but also of breast milk of preterm babies and babies with special medical needs will better allow us to understand the therapeutic potential of these individual bioactive components, either individually or combined for the future. Thank you for your time today, and thank you for being the best advocates, along with parents, for children everywhere. Thank you.
I would like to thank all the participants of the NNI96 workshop on strategies in neonatal care to promote optimized growth and development, focus on low birth weight infants. On behalf of NNI, we would like to extend our appreciation to the chairpersons and the speakers for sharing your expertise with us. We hope that with all the learnings, we can better improve the health outcomes of these babies born too soon and too early. Thank you.